Okay, welcome to video 6 in this series, right? This is video 6 in the series. In this particular video, we will be exploring the other two components that would seek to build the suitable vulnerable conditions and increase the likelihood of loss of property, loss of lives affected by volcanic eruptions. Okay, so we will be focusing specifically on the conditions that will help in the development of lahars, which is availability of surface and groundwater, and also the impact of prevailing wind conditions in spreading the ashfall and tephra, and hence widening the disaster risk of the eruption to the larger region. So first and foremost, let's take a look at availability of surface water and groundwater. Now, when you are looking at lahars, right, what is needed? You need lava, okay, and next you need a available amount, substantial amount of surface and groundwater, okay. Otherwise, there will be no lahars that can form because lahars basically is a form of lava that is mixed together with your water. It comes down like a superheated form of mud flow. Okay, so when you have rapidly melting snow caps on volcanoes, that is one issue. You will have the potential of forming lahars, right? If you have groundwater that is right below the surface that comes out because of the cracks that occur and because of fractures that occur, because when you have volcanic eruption, there will be rumbling as well. So you may have groundwater that's released to the top, or worse still, if you have rainfall that's existing in the midst of a volcanic eruption, this could all lead to the formation of lahars. Okay, of course, some places have rivers and lakes that are running along the volcano itself. You may have a very large volcano, and these all play a part. Now, what happens when you have lahars? Okay, it just increases the vulnerability of people and properties. You may not be able to outrun the lahars, even though, reminder again, earlier on we talked about lahars going up to a maximum of 220 kilometers per hour. Even if it's at 100 kilometers per hour, you're not going to outrun it. Okay, chances are, with everybody trying to evacuate at the same time, your cars may be caught in a situation where even driving, you cannot outdrive a lahar. Okay, so what will happen is you will then have a lot more damage that's brought about not only by the volcanic eruption, not only by the trembling and land soil shaking, but also a third thing, which is the lahars coming down slope and then destroying everything in its path. Okay, so this is a lahar, impact of lahar. Now you may be thinking, why are these three people so calmly, casually looking at this? I wouldn't say they are calm and casual. I would think that they are helpless. Okay, in a situation where whatever is, they know for sure whatever is caught in this path, right, is going to be swept away. Okay. Now, the final thing I want to cover for this very, very short video will be prevailing wind conditions. Now, when you have a volcanic eruption and you have ash that's ejected up into the sky, right? Depending on the height of the ejected material, if you get caught within a wind that's running in a dominant direction, it will be spread in that direction. Okay, but what goes up must come down. So eventually, this ash will come down, will come down further away from the volcano itself, and they will be deposited onto whatever area they are currently over. Now, if the eruption, for example, is from Merapi in Indonesia, and then there is a wind from the southwest, okay, guess who will benefit from this increased ashfall? It will be us, because the wind coming from the southwest will push all this up towards the northeast, and guess where we are? We're in the northeast of Mount Merapi, right? So similarly, in the other diagram that we saw a couple of times in earlier videos of Pinatubo, and we talked about it earlier on. I told you that I experienced Pinatubo's eruption. In Singapore, the thing that we felt was ashfall. Okay, it was very fine ash for a couple of weeks, but it's very far away from us, yet we still get hit. Reason for that was the prevailing winds were in that direction. Okay, we were facing the northeast monsoon where we are, and as a result, it comes down. Now, these prevailing winds, right? If you get caught with the monsoonal winds, they are a lot stronger, and as a result, they can actually hold the ash with them and deposit them further away. Okay, of course, if you're really very far away from the volcano, you may suffer very little ashfall to the point where some people will not feel it. Okay, but having gone through the many years of haze, we now understand and have a very clear understanding that what you cannot see may still kill you. So the smallest microscopic particles that are ejected out may be too small to see with the naked eye, but it may still impact your area. So keep that in mind. Okay, so direction and strength of the wind are both very important in this case. Right? Exposure. Finally, we will continue with exposure in the next video. So I just want to have a very short video here to give you time to think about this, right? There are so many differences between impact of a volcanic eruption versus impact of an earthquake. Okay, earthquake tend to be localized, tend to be within the country, unless of course the boundary is between two countries. It tends to be very impactful to people living there. You tend to have very little reaction time. Um, you can mitigate against it, but you cannot stop it from happening. Volcanic eruptions, similarly, you can have plans to mitigate. You can not stop it, but it gives you a bit more lead time. So keep this in mind. The key difference when you're talking about these two, right, in terms of what kind of disaster risk and the severity of it and the possibility of us mitigating against it, you should come from the angle of lead time. Volcanoes do not erupt suddenly. Okay, or we have never actually documented one that erupted instantly with zero warning at all. It always has some precursors, be it a couple of days of rumbling, the dome expanding, sighting of increased heat in the region of the volcano. There is always lead time of at least a couple of days. So you cannot claim that, oh, there's no lead time at all. There's no way to prevent volcanoes. That's true, but and we don't know when it's going to erupt. You know when it's going to erupt. It's through sheer stubbornness that you don't take evasive action. Okay? So if you're going to talk about which one is more serious, right, all other factors held in place. Okay, intensity, distance, and all held in place. I would argue that earthquakes are a bit more problematic because you cannot tell when the earthquake is going to strike. Okay, even with the best tectonic sensors, right, the seismographs, the seismic meters, at max maybe you get 2 minutes of lead time. Okay, 2 minutes lead time of warning, which is really godsend already, because 2 minutes you can do a lot to save your life. However, if you have a week in advance to prep that, okay, I think the volcano is going to erupt, right? There are some indicators. Let's check for more indicators. You have 3 days, 2 days. Even if I tell you have 1 day, 1 day is a lot more than 2 minutes, right? So if you're comparing disaster impact, right, between volcanic eruptions and earthquakes, this is one good way to look at it. Okay, so take some time to think about this. You have to formulate your own strategy when you're going into the exams, when you're facing exam questions. Because I want to repeat this, anything can come out, right? Anything within your syllabus can come out. Okay, so take time, think about it, think of how you want to formulate certain approaches, right? And if you have a solid argument, you want to run it through your teachers, I think your teachers will be more than happy to listen you out or to read something that you have already created as a paragraph. Okay, so I'll see you in the next video.